Now there is another power controller, which is the inverter. Okay, inverter. So inverter is different for different types of motors. So if we want to cast, so it is a very large in literature, and then the discussion time uh, for hours and hours. So I have combined it to some things like say induction motor control. First of all, and just few glimpses, because induction motor control itself is a very large topic. Induction motors are usually not designed, say 48 volt or something, say 36 volt. Uh, Normally they are designed at minimum up to 100 level. Therefore, but you have a source. Most of the sources, they give you a conversion. Most of the DC converters, they give you a conversion range of around 4 times maximum. So if you go for if you go for say 12 volt, so you get a DC rail of 48 volt at the most. Okay, you get a DC rail of 48 volt at the most. So therefore, actually, to drive a motor, induction motor from 48 volt DC rail, it is, you cannot do it. It will go for always lower voltage. Level topologies where we have several low voltage sources and they are cascaded together. Okay. They are cascaded. Cascading of say R phase, Y phase, and B phase for the source. I have shown many. Of course, if it is 110 volt motors, comfortably 3 such 48 volts are actually done, and then the level is so this is an 11 level thing, and there you will have 7 level converter. Now, what is level actually? Now, when you switch on these converters like this, stage by stage, say 1, 2, 3, like that. So I think you have read, a few of you have read multi-level topology. Then you get a waveform stepped like this. Okay, like this. So this is for fifth, this is for fourth, this is for third, this is for second, this is for first. So I have shown you 1, 2, 3, 4, 5. They are switched like this, and you get a waveform like this. So this gives you several advantages. First advantage is that you can use low level voltage sources comfortably. So instead of going for 4 times boosting, you can go for 3 times boosting and have a multi-level inverter there. So it can be easily driven. Okay. Secondly, you see the waveform nearing sinusoidal. Okay, so you don't need additional switching or additional, you can say PWM in most of the occasions. So there are techniques available these days which actually optimize these angles so that these angles are switched on in such a manner that you get that lower order harmonics automatically eliminated from the voltage waveforms, right? So these are the techniques coming up that have already come up and has been in vogue for last 10, 15, 12 years. Now this is actually the technology I'm telling you. MLI, multi-level inverter technology, induction motor control. And then this is inverter technology, but ultimately the control is with, say, FOC, field orientation control, or DTC, direct torque control. So those two things are again need you lectures of several hours. Very voltage frequency. So this is the system configuration I have shown, that this is the batteries, and then they are actually coupled, connected in cascade like this, and each unit is having this edge bridge type, this one, and then we can have configurations like this. When the switch is here, so it is supplying to the motor. When the switch is here, this is open. Now it goes to the charger, so battery gets charged to this converter. They can operate in such a mode. So this way actually, this can operate system configurations. Now if you see the efficiency comparison, so people go for that. Now it's a normal commercial inverters, and this is the fraction of inverters rated output power, say 20%, 40%. That's what I am telling. And I was telling also earlier, the maximum efficiency for these converters are always near unity load, per unit load or rated load. So you see the efficiency is rising, and they are reaching the best around say 85%, 90% of the rated load. So now you see the overall efficiency for the multi converter is much higher compared to the commercial PWM inverters. Okay, normal PWM inverters of 3 level or 2 level like that. Okay, so therefore, actually, that the image technology is coming up slowly. But the disadvantage again, I have to discuss. That you should be concerned. You will be doing some research. Few of you at least come because we are using these here. Say instead of four or say 3 phase 6 switches, we are using so many switches here for this configurations. So the chance of failure is much higher here. But thanks that this switch voltage stress on this switch is less. So therefore, I mean, we can choose the switch, but overall cost increase. So therefore, all these considerations have to be taken care of, whether you require more reliability or the type of control or etc. And again, when you try to apply FOC on this multi-level converter, FOC or DTC, I was talking about, so it becomes a difficult one. It becomes a difficult for switching schemes. So therefore, also, I mean, considering all these factors, so we have to decide when you become an engineer or a researcher or modify this technique to better one so that people can use it. This is my honest request to you, that you also be part of the research team on this topic. So it is very emerging field. So then I think I don't have time. So I thought that what we had developed in that how we control reduce the torque ripple. I'll just discuss in 2 minutes that what is the drawbacks of various like as I have said, that DTC for induction machine and BLDC machine. Now, for low speed, so we have a commutation, right, for BLDC machine. Commutation means what? Of current from one phase to the other. So during that time, actually, it may so happen that when phase A current has reduced to zero, phase B current has not risen up to its value where the phase A current was. So therefore, if the time taken by both these windings become different, because the parameters can change, saturation level can change time to time. So then, actually, the torque expression, if you express, will have some ripple in it. And at the same time, this also switching at lower speeds, you will find a speed ripple, and as a result, torque will come. So due to which actually the quality of the drive, the performance of the drive gets deteriorated. So whenever you are riding a car, you don't any jerk. Ripple means a small jerk. Okay. So then actually there are techniques, there are many technologies major factor for say modern day in vehicular drive system, that smooth drive, and second thing is reliable drive. Okay, so then we had something on the torque reduction regarding, say, these are the back EMF sensing and all, and I do here because everything cannot be discussed in lectures. But remember, torque is one of the major drawbacks of this kind of drives. And then people are working behind it for long, past 10, 15 years, and even now, it is not exactly solved. Those who are theoretically, but practical implementation becomes difficult when you go a drive system of 3 kilowatt, 5 kilowatt, 8 kilowatt, like that. So this is okay. So with this, I end up my session. So I would request you to come forward with few questions what you have my delegation or my interaction with you. Whatever.
Thank you, sir.
Thank
Thank you
you.
very much, sir, for your informative and very detailed lecture. We get to know many things regarding the technologies which are pertaining to electric vehicles, especially the battery management system, the different motor characteristics, then the different kinds of drive which are needed for different kinds of motor, including the multi-level inverter and interleaf boost converter. These things were highly informative, and it also throwing light on the possible areas of research which can be taken up by people who are willing to work and research in the area of electric vehicle. So uh, I want to thank you profusely. I want to thank you very much on the behalf of management of BBIT, the Department of Electrical Engineering, that you find some valuable time and gave us such a nice and informative lecture. Especially the content of the lecture was very detailed, and I also get to learn many new things with the lecture of yours which you have given now. So I want to thank you again. And what I want to conclude here as a human being is that the environment, the degradation of environment has been a concern by us for a very long time. And as you have mentioned in your presentation, that 23% of the greenhouse effect or thing
Gases.
is coming from transportation. So if
Yes.
we, the people, as well as the government, both of them are united and like-minded, that let us save our environment and let us reduce the pollution by adopting certain policies which will encourage the people to buy electric vehicle, so that more charging stations will come up like the petrol pump. So we will save our environment, and if we save our mother earth, then it will be some sort of gift to our future generation, because we the human being are responsible to not tamper the nature. What is happening nowadays is that uh, the technology has advanced to such a level that human beings are increasingly interfering the nature. And the dangerous part is that we are able to interfere with the nature, but we are not able to uh, what should I say, we are not able to correct we are not able to correct the changes which is happening at the basic level, like the ecosystem or the food cycle, everything. So I just hope that all of us take some sort of learning from this webinar, that electric vehicle, if we adopt or if we are thinking of using electric vehicle, then it will help to improve the technology. It will help the people who are working in the area of electric vehicle, and then hopefully we will reduce the greenhouse emission, so that will save our mother earth. Thank you, all of you. Now I would like to hand over the session to our anchor, Mr. Afaq Wajid. Thank you.
Thank you, sir. Yes, sir.
Okay, can may I ask one question, sir?
Okay, okay, definitely.
Sir, what I am saying is that let us imagine that if we are going to use this electric vehicle in huge numbers in near future, say by 2030 or 40. So life is over, I mean to say, how we are going to deal with the disposal of the batteries which has been used, or say it has life has crossed. Those things I was wondering, sir.
Thank you for your very good question. At least I'm telling you that this is the major concern. But nowadays, a parallel research has been going on by the chemical side. Actually, how to recycle these wastes. Like, say, if you are using a lead acid battery, so now the leftovers for the lead and acid, that can be recycled, and that can be used in the next new battery. So this is another. Then if it is a say other type, say what is that, lithium ion. So process or recycling technology, that is becoming another research topic parallelly. Okay, so
Okay,
then waste will not be a problem. One
okay,
thing is
sir.
that how to manage, because see, the main constraint we have, just 1 minute I'll take, the main constraint we have, these vehicles are not like say normal petrol fired vehicles, simply because whenever you see your and they fill up and then next minute you start, right? But here the charging and discharging time is a factor. So when you have so charging and discharging, charging at least, because the charging time nowadays is not less than 4 of say 30 kilometer or 40 kilometer like that. So therefore, this is the main constant. So I was attending government of West one they called me from this institute regarding. So they are also planning to set up many say charging stations, and new buses have arrived. Also, you are seeing. So 9,000 buses are also coming. So the government directive is also coming, so that we can shift our focus slowly to the electric vehicle technology. But recycling technology is actually the another research area these days for chemical portion. So we don't have that. We are the application part actually. We are dealing with the application part mainly.
Thank you, sir. Thank you
Okay.
for your. Thank you, sir.
Thank you, sir. Any further questions from anyone? So now I would like to thank.
Namaskar, sir. Namaskar, sir. I am Partha Chakraborty. I am the student of BBI as a M Tech. Sir, you well know me. I am working in Institute of Engineering Management. You came in our college for giving the seminar. So, sir, one question arises me, sir. Uh, what is the benefit if in IGBT control or chopper control in electrical drives?
Oh no, you cannot say like that. IGBT control or chopper control. See, these
Hmm.
devices that we use to control. There are two converters. I have said. One converter is for driving the machine, and
Hmm.
one converter is for, I mean, getting the DC rail voltage, proper DC rail voltage, isn't it? DC bus voltage. So then one becomes a DC to DC converter. And another is the charger, battery
Acha.
charging. So these things are actually implemented with the help of devices, say IGBTs, somewhere MOSFETs like that. So advantage means you have to use that in these days, because other better devices are not available compared to IGBT. Huh?
Okay, sir. Okay, sir. Thank you, sir.
Got it?
Thank you.
Sir, thank you, sir. You have mentioned that you have another lecture from 1:30, so you need time for your lunch.
Lecture means class actually. Our students,
Okay.
our online classes are going on.
Yes, sir,
Okay.
but your lunch is also due. So
Okay, no problem. You can ask me
our
another 5 minutes.
no,
Another
sir.
five
No,
minutes you can take.
so what I am saying is that if you were in our college, then we would have the privilege of having the lunch with you. But since this is a virtual thing, so we are unable to
Okay.
conduct that thing. That thing you want to mention. Okay, sir.
Okay. So I missed the lunch. So that that's what
Yes,
I'm
sir,
telling you. I
we
can
also
tell.
miss your company, sir. We also miss your company very much.
Okay. So my best wishes to all of you, and I
Thank you,
think
sir.
you will also come up with some few research areas, with some few research works within this area, and you can get enlightened from the others also, who will
Yes,
be
hopefully.
delivering delivering their sessions later on. So okay, so I wish a very we can say grand success for this topic and for this seminar, as it is chosen
Thank you,
at
sir.
the right juncture of time, because nowadays the demand is that. So I would again thank you, the organizers, for choosing such a very good topic, which is quite relevant these days, and energy, and it will cover the area of energy and then other technologies for environmental safety and all. So those things. So okay, with my best wishes. So hmm.
Thank you, sir. We also
Thank you,
extend
sir.
our gratitude for joining the webinar and enlightening with your lecture. Thank you, sir.
Okay. Thank you.
Thank you, sir. Thank you, everyone. Thank you. I would like to thank all the dignitaries also for being present, and faculty members, entrepreneurs, industry professionals, and PhD scholars who are all present over here. And definitely, let's not forget our students who are watching our live stream. So, I would like to inform you all that the second session will be starting from 2 p.m. onwards. So, please join us at 2 p.m. for the second session, which will be presided by Dr. Jitendranath Bera from University of Calcutta, and he will be discussing demand side management.
So I leave now, huh? Okay. So
Yes, sir.
with your
Yes,
Yes,
sir.
permission. Oh,
Thank you, sir.
thank you,
oh,
sir. Thank you for coming,
oh,
sir.
Okay, sir.
oh,
Thank you,
oh.
sir.
Thank you.
Thank you, everyone, for joining us in this session. Looking forward to meet you in the next session, which will start at 2 p.m.